Hopefully you can also see my screen. This is the startup screen of DNA Center. As the rest is mentioned, for the remaining of this session, we'll stay in demo. You probably learned over the last 30 minutes, if you didn't know, that the DNA Center can do a lot, but the focus of this demo will be assurance health with a special focus on wireless. So let's go to, before we jump into wireless, and we'll do a couple of common troubleshooting techniques of isolating problems or troubleshooting a specific user. I just want to take you through real quick what I refer to as the good morning screen, right? So this is everything condensed, very high level view, starting with your network devices health, and we'll go over how we calculate that here in a second, but we can see how our network is doing based on the devices, from access point to all the way up to a router, switches, etc. And we, at the same time, we can also see how our wireless clients and wired clients are performing, right? We can see the health score for those high level view as well. So we can quickly and easily isolate problems. If I see a drop here in the percentage, I can go and continue to troubleshoot. Some other important facts here on the good morning screen are some of your network services, which are very important. The AAA, which is your radius authentication, that will be bad if something is going wrong there and users cannot onboard. Just like in prime infrastructure, green good, red bad. I can see that about 15% of my radius transactions have failed here. And I can see that about 11% of my DHCP transaction has failed. So if I wanted to continue to troubleshoot, I can follow the hyperlinks on the bottom and it will change the focus to that particular service that I'm looking for. At the bottom, we have the top 10 issues. For those of you that have been with prime infrastructure for a long time, this was probably a #1 complaint, that with the alarms in prime infrastructure, the top right, we had that 999 plus, right? And a lot of folks used to just completely ignore it, right? It took time to kind of go through it and fine tune it. It was quite a bit of a daunting task, right? Now here we give you, first we give you the top 10 issues, right? So we prioritize them by priority, P1 through P4. And we can already see that since this demo was focused on wireless, we can see some wireless device rows here experiencing problems. If I wanted to go, I can continue from here and troubleshoot a particular issue. I can click on it and it will bring up, this is a category, right? So it's a category of issues saying that the AAA server rejected clients. And I can see that that particular issue happened on 2 access points, that 9124 and the 4800. I can go and continue to investigate and it will give me certain things of, more details about the problem, what SSID I was on, or what the user was on, when it happened, how many users are impacted. I can see 1 site, I can see 2 impacted clients and 1 impacted AP, very high level view, right? I continue on here and just get more and more details, get the impact details of, which computers are, and I'll have a list of them on the bottom. I can try to get some root cause with MRE and run through that as well. I see that the radio server was down there. That was what was given me, as well as some suggested actions. And those suggested actions will be kind of a best practices with the first common sense task that you do when you're troubleshooting. Something very similar, like if you open a TAC case for that issue. Now you have those suggested actions for you to do on your own before you actually engage TAC if you wanted to. So, check on the AAA server, et cetera, et cetera, et cetera. Okay, now Orestes mentioned something about AI. I don't have, let me switch systems real quick so I can show you. In the previous one, I did not have any issues with AI, but here I do, and I can show you that the issues that are identified by AI has that little AI icon in front of it. And, I can see there's a couple for wireless as well. I can see that there's some failures to connect, high deviation from baseline. And if you recall what Orestes mentioned, is that's how AI learns it. It baselines your network. And if there is deviation from the numbers, it will bring it up to your attention. And so I went and clicked just to show you real quick. We've already been through an issue, so just not to waste time. This is how it goes through the deviation. The deviation is shaded with a light green here. Hopefully you can see it. And it marks it with red for the time period that it went above the deviation. So if I hover over, I can see that my predicted upper and lower limits are 22% to roughly 9% upper and lower, but at this particular time, the failed were 43%, which is pretty bad, right? And similarly, I can continue on, see what the impact is, even though I see here that it's one site with 8 clients. I can get root cause analysis, suggested actions, and continue on down that path. Okay, let me go back to my previous so I can continue from where we were before. Now, with the focus, let's look at the network devices health real quick and explain a little bit before we go down to the wireless troubleshooting. The health scores in assurance, the scale is 1 through 10, 1 being the worst, 10 being the best. And you can actually easily see that by hovering over any of those graphs in here that I'm showing, but I'm going to hover over the access points. It tells me that 1 through 3 is poor, 4 through 7 is fair, and 8 through 10 is great, right? And how do we calculate that value? It's a single value per device. As you can tell, we have access points, controllers, and so forth through switches and routers. That single value is calculated for the devices, is calculated based on physical specs and their utilization, such as CPU, memory, interface utilization, maybe some errors. And actually, you can see here that it gives us a little bit of a clue. It gives errors poor and memory poor for some of the switches. With the access point, we'll add some more variables. Since it's wireless, we see some noise fair, interference fair. So those will also be calculated into the single digit health score for that particular access point or that particular device. Now, what do we mean by 83% of your network devices is healthy? Or what does that 83% mean? The beauty of the DNA Center is everything in here is, if I hover over, it will explain exactly what's going on. It's telling me that 83 of my devices are in a great health score. That means 8 through 10. The rest of the 17 are not. And if you follow on the bottom, it tells me it's for the last 5 minutes. Why for the last 5 minutes is because by default, I'm in the latest. And if I hover over the latest, it will tell me exactly the timestamp that I'm looking at. So after 5 minutes, this will be recalculated, right? If I wanted to focus on a particular, let's say that I want to focus on the one that are poor or fair. If I wanted to troubleshoot the access points or see which access points are in poor condition or poor health, everything here is selectable. So I can just click on it and it will filter down only the access points. It will show me only the access points that are in poor health at the moment. I can see device breakdown. So I can just note, I can see that right off the bat, it's not a single model of AP. We're looking at 3 different models. And it's only 1 each, so it's not a super big deal, but I can keep scrolling down and I can see their health. I can continue on and troubleshoot each one individually. For the sake of time, right now, we're going to continue on with some other troubleshooting here. Before we move into the client health, I want to show you a couple of useful dashlet here that are related to wireless. For example, the busiest AP by client. So I have, by hovering over, I see that AP 4800 is the busiest. It's 15 clients, not a big deal, but this dashlet allows me to eliminate what we call magnet APs, right? An AP that can attract many clients. And there may be various reasons for that. Maybe the transmit power in that AP is higher than the rest of them, or maybe the area needs additional AP for additional capacity for users. But this will allow me to do just that. Or another popular one is the interference. I can see which AP have the worst interferers. And this is 80% because it's on the 2.4 gigahertz. I can switch it to 5. And I can see here, it's about 60%. So that's an AP that it's in a pretty busy area. As we can tell, it has some clients on it too. But a quick and easy way of actually identifying problem areas or problem APs that potentially can hurt our overall health score. All right, so let's go into the client health real quick. And here now the focus is on wireless and wired clients, of course, on the right. With the wired clients, it's either up or down, right? Once the wired client is connected, it pulls an IP address, it's state run, right? It passes traffic, so that's why you see it usually higher than the wireless. With wireless, we do have more variables, right? We have signal to noise ratio, we have signal strength, etc. So I can actually go and demonstrate the first troubleshooting scenario. In this case, we'll look into a problem where it was reported that multiple users have poor experience on the wireless LAN. And by poor experience, maybe just sluggishness, Web pages are taking longer to load. Maybe some voice and video calls are bad. So for that, I'm going to pull this view details for the wireless client health, and everything is broken down here by category. So I see that out of the 249 clients that I have at the moment on the wireless side, majority of them, 90% of them are in the good condition. Automatically, I'm going to actually eliminate those, right? If they're in good condition, most likely they're not going to complain of performance, right? And this is this top-down approach, right? I don't know much about these clients. I don't know where they're located. I don't know exactly who they are. It just the help desk told us that it's a few users, but we don't have details. So all I'm trying to do is eliminate variables and come with common denominators, right? Try to divide and conquer. We know that I see the 15 clients are not able to onboard. It doesn't really match our criteria because if they're not onboarded, they're not going to complain of performance. They're going to complain that they're not on the network, right? They won't be able to get to anything. So because of that, I'm actually going to focus on this fair connectivity. And as you know, everything is here is selectable. I see that just hovering over, it will tell me there is 9 clients, right? That are bad. So I'm going to select it, 9 clients that are in fair connectivity, sorry, not bad. And I can, now it will be filtered and those 9 clients will be listed on the bottom. But here I can quickly and easily eliminate some variables. For example, it's not a single SSID. I see it across multiple SSIDs. I see it across a multiple device types. So I cannot say that it's a single device type that it's having the problems. And it's across multiple access points. But one little piece of information here is catching my eye is that the top location, it's primarily this one floor, the floor 1 in the San Jose building. And if I hover over, it'll tell me that 8 of those 9 clients are on that floor, right? So that gives me a good clue that maybe something is happening on floor 1 in the San Jose 1 building. If I go and continue to look through this, I see the listed clients here on the left. I can look at each one of them before I dive in. We can actually look at a couple. But if I hover over, since we covered how we calculate the client, the device health, the client health is the same scale, 1 through 10, but we do take a little bit different approach into coming with that number because it's wireless clients, right? So just by hovering over, and if you can see the fine print on the bottom, it will actually tell us how we calculate it. It's an aggregate of the client onboarding status, which in this case, you see the green dot there saying that it's passed, it's onboarded, it has an IP address, and it's passing traffic. That's what it means. The second aggregate that we take in there into consideration is RSSI, which is the signal strength of the client. Pretty good. Neg 22 is actually very good. And we give it a top health. But the signal to noise ratio, which is that SNR value, and that's the delta between the signal strength and the noise floor, it's very low, right? It's 8 dB. We would like to see that in the, at least double digits, hopefully 25 and above in general. So I can see that in this case, I see low SNR as a problem for this particular first client. I can keep going down. The next one has low signal strength, but also low SNR. And if I keep going down, I see another one that has SNR. So you see, it's almost like forming a pattern here. And I see that the signal to noise ratio is one of the culprits. I see a couple that are offline. So if I keep going down, there's another one just like that as well. And I know that they're all in the San Jose building, floor 1, right? So what else can I identify through here? Well, look at that. I can actually see the band, and it should not be surprise to anyone that actually it's on the 2.4 gigahertz, right? So now I know that I have issues with my noise floor on the San Jose 1 building, floor 1. And I can continue to further investigate. Maybe I can take it to the team that I'm working with and discuss what we can do additionally. It's easier said than done to clean up 2.4. We know that we have only 3 non-overlapping channel in the US, 116.11. It is very prone to interference from Bluetooth, microwave overs, et cetera, et cetera. So maybe we can use that as maybe go and do a site survey or something of that fact. But with that data, I can continue on troubleshooting, and I know sort of what's going on in here. I have a good lead to go and continue troubleshooting. Now, this band here is not by default, is not on that list. So if you didn't see it, you can always go in here and you can add it, right? So it's not on by default. You can always add it yourself. There's a bunch of other information that you can add. So if you're trying to eliminate some of the other factors, just go through this list and add whatever you need to add in here. All right. So a couple more things before we go to that wraps up the first troubleshooting scenario. So that illustrated this top-down approach. You always go at high level and kind of try to focus and eliminate the problem, right? There is a ton of good information in this page here via dashlets. We give you the concept is it will give you the different breakdown of clients and their KPIs or key performance indicators. I can actually look at this connectivity signal to noise ratio and notice that if I hover over the clients that are with 10 or less signal to noise ratio are the same 9 clients that we're looking by going the long route and troubleshooting from the actual wireless client's view details, right? So if I wanted to quickly eliminate, I can go into view details here and do exactly the same thing that I did the long haul through eliminating it from the top. Okay, again, bunch of good information. Some of the most popular are also the client count per SSID, right? So I can see which is my most popular SSID, and almost 85% are using this guy. But I can quickly and easily pull that information and find out, what SSID is the most popular one. The last one that I want to show you, it's on the bottom. And this is the client count per band. This is very important. It's usually the first task that it would like to show that the more clients on the 5 gigahertz, the better, right? So we can alleviate the problems with 2.4. And this is the case in this scenario here. We have almost 87% of our clients are on the 5 gigahertz, which is fantastic. That's what we want to see. But also with that piece of information, maybe I can go to my team in relating it to our previous troubleshooting scenario. Maybe it's time to remove the corporate SSID off of the 2.4 gigahertz band to begin with. It completely bypassed this problem with the signal to noise ratio. I can put those two data points together and kind of come up with a better solution, right? Okay, on to the next one. The next scenario here will be an user that call in. We know what the user is. Her name is Grace Smith. And we can use, the user is complaining of intermittent issues when onboarded, when already on the network. It kind of drops and it has hard time getting back on the network. So just like Prime Infrastructure, I can go in here and use the magnifying glass and search for MACs or usernames or whatever. I'm going to type Grace and it will just pull up everything that it knows about that has a match as an entry. I see that there is a user called Grace Smith. So if I click on that and then follow to the user 360. Now, real quick, what a 360 concept in DNA Center is, it's a focus on an entity. It can be a user, what we're looking at the moment. It can be a device. So if I click on one of those devices and go to the device 360, now my focus is on device 360. It can be a switch, access point, router, application. Basically, when you hear 360 is a focus on an entity in DNA Center. Now, the beauty of the user 360 is I can see all the devices that Grace Smith has used over the last 24 hours. Now I can change that and go back to 7 days, go back in time if I had to. But the description that we got for this problem that it just recently happened within the last 10 minutes or so. And so I can see all of her devices on top. I see an iPhone, a PC, but they all look green, right? You see that the icon next to them in a circle, which shows green 8s. Those are the health scores of the devices. So I can see that the health scores are pretty high on all 3. Now her iPad has a 7, but it may not be health score related, right? So if you notice here, I have on the sliding graph here with the 24 hours, if you hopefully can read it, there's health on the top. So that line on the top represents the health, and I can see it going 7, 9, right, 9, 10. It fluctuates, but I also have events on the bottom, right? So events are the squares that you see on the bottom, and I see there is an onboarding, but I see some red events here as well, right? So I see first there's a little red event right here saying that there is an onboarding problem right under my cursor, and there is a delete. I also see that there is a broadcast rekey problem in here. Okay, so that gives us a little bit of a clue to maybe even search a little bit on that and focus further down. I can quickly and easily get more information about this particular iPad by looking here, IP addresses. I can see the VLAN that it's on, what are the capabilities of the client, et cetera, et cetera. I can continue on down this path, right? It has the issues. We already demonstrated the issues. We're not going to go and troubleshoot the issues for Grace Smith, but you can see that it's also complaining that there may be some WebEx problems because the threshold of 260 for latency was crossed. So you can continue on down this path. Now, I can also see a visual logical topology representation starting from the client through the SSID that it's connected. And I can even see the AP, and it's that same AP 4800 with the 15 clients on it. By hovering over, I can go and switch my focus. So if I wanted to focus on the AP troubleshooting, I'll click on device 360 and it will take me to the AP focus, right? Now, at this particular moment, I don't want to do that, but I can do the same thing for the controller. I see that it's connected to a 9800. I can go to the device 360 and continue to troubleshoot from the controller standpoint. Now, what's interesting here is before we look at the event viewer, I'll show you how you can get a little bit more information. On the bottom is all the detailed information that we looked at the top for the 24 hours, but a lot more in detail. I can see connectivity, how much traffic is passing, transmit, and receive for that device. I can also see some RF statistics, such as signal to noise ratio or signal strength over time. And the last thing that I wanted to show you here is the iOS analytics. Now, that's a direct product of the partnership between Apple and Cisco that has been going on for a few years now. And this is how the client actually sees the network, right? It shows me the AP nearby, either in the visual representation, so I can kind of see, what's their signal strength and potential target to roam. This is how the client sees the network. Until this point was how the network was seeing the client, or the KPIs that we're looking for. Very powerful information. And then on the right over here, I can see some of the disassociation reasons. Like I can see that maybe a user completely disconnected from the network. There's a device idle, which means that the iPhone or the iPad went to sleep. But we have something similar for newer Samsung as well as Intel. So we're working with multiple manufacturers there. The client manufacturer, this will be information provided not just for iOS, but also for some Samsung phones, and in the future, more and more Intel and so forth. Okay, back real quick to our events. Quick time check, we have a few minutes. The event viewer is very powerful. So for those of you that have been in the wireless field for a while, they're probably used to debug client MAC address, right? So this is something you usually have to collect for TAC, or if you're doing the troubleshooting yourself to get detailed information of the stages that the client is going through. Well, the problem was that the first was very cryptic, and then you either have to rely on our debug analyzer tool that has to translate it into plain English, or you have to rely on Cisco TAC to do the troubleshooting for you. Here, the beauty is that first it's in plain English already, and they're grouped nicely together. Now, this is kind of like a debug analyzer, but summarized and well organized, right? So I can see that within the last 30 minutes or so, there was a couple of red events. So I can double click on those and see what's going on in here. This one looks like a DHCP failure. So it goes from association and starts up, right? So show me 802.11 association. It will go through the authentication piece, which is the .1x. It tells me .1x full auth, right? So I can see that it's a full authentication. It's successful because it's green. Then it did the four-way key handshake for the key exchange. And I see this DHCP failure. So if I click on it, it gives me a little bit of information. But most importantly, not even a millisecond later, I see that there is actually a DHCP that it was learned. So it's successful DHCP. So this event in particular, the onboarding, seems like a false positive to me. So I can probably kind of eliminate it for now. What I can do is come in here and look at that broadcast rekey that also has a red. Now, if I click on the key exchange, I don't have a lot of detailed information, but most importantly, I see this PCAP behind it. If I hover over it, it will tell me that packets were captured, right? So what I can do is go back to this intelligent capture button, and I can actually go and see packets that were collected as part of the anomaly that was collected during that particular event, right? And so I can see the same events on the left, right? And we say that onboarding, I see this broadcast key that we're looking at. So if I expand that, I see some key exchange problem. If I click on that, it's going to go and filter on the right the data for that particular event, right? So here real quick, while it's loading up the map, I can see every packet from a management standpoint. If I had a dedicated AP doing packet capture, that intelligent packet capture with its dedicated radio, like a 9130, I can actually see even the data. But here, I see just management frames, which is good for what I'm trying to accomplish, because I know that there's a problem with the key exchange, which is part of the management authentication of the client, right? So you see, if I scroll down a little bit more, you can see the legend that a triangle pointing up is a packet coming from the client. A triangle pointing down is a packet coming from the AP. So I can see it going through its authentication, 802.11 authentication that is, and then going through its associations. Everything is green until we get to this level over here, where I see that there is a packet coming from the AP to the client, right? And this is that broadcast rekey. It sends it. It says it's an EPOL packet coming down, and you see the packet number, which is packet number 17 in that pop-up that I've shown. So I see one packet. Essentially, the AP is trying to rekey with the client, but I don't see a packet coming back to the right of it, right? So I see another red packet, which is packet number 18. So the AP is again retransmitting one more time, trying to rekey. And a third time again, I see the 3 in a row. And by default, that's the logic there. 3 strikes and you're out. I bet that last packet is probably the authentication, which it is. So the AP attempted to 3 times to rekey. The client did not respond. And the controller, by the nature, it will try to clean that entry in hopes that the client will come back, which is exactly kind of what happened. If you look at the next event, there is a successful DHCP on the left side here 4 minutes later. So the client, for some reason, either went to sleep or was not responding to this, maybe stepped out of the coverage area potentially, and failed that key exchange, and therefore it went off the grid for a while, right, for 4 minutes. Now, that gives me a pretty good idea of what may be happening. I can take that information to Grace Smith and talk to her and figure out if that timestamp matches exactly with the experience that she had on the wireless network. Now, it can be anything, right? It can be a driver related. It can be an iOS version related. We don't know, but we have a good idea and direction where to go and to continue troubleshooting, okay? And that kind of wraps up the second scenario that we had for a single user troubleshooting. I know I have a couple minutes. Was there a question?
No questions right now, Zach.
Thank you very much, sir. So real quick, what I want to show you in a minute or two here, I'm going to switch to a different Cisco DNA center here that I know that it has some 6 gigahertz clients. So you remember Orestes showing us that Wi-Fi 6 dashboard or dashlet. So I can go to Assurance Wi-Fi 6 in here and kind of leverage this information to see where I stand on adopting 6 gigahertz, not just from my infrastructure, but also from wireless capabilities, right? So even if I don't care, I can kind of, meaning don't have enough time to care and troubleshoot and examine each network readiness here or the client compatibility. I have insights at the top that I can just read, right? It tells me 10% of my clients are 6E or that's your 6 gigahertz capable. Right? And what does that mean? Well, you may say, Zach, how do we know that, right? Well, clients will advertise their capabilities, right? They will do that in their probe request to the AP, and they'll say, what data rates they support, what bands they support. That's how we obtain that information, and we analyze it via DNA Center here and provide it for your analysis here, right? So I can kind of see that I have some Wi-Fi 6E clients here, the top 3 of them, and actually 2 of those, or 6, and then 5 of those are on, and some of them are not, right? So I can continue on to troubleshooting. I can do the same thing with my network readiness. Now, I just wanted to really show you quickly how to do it. I can also see how many APs are 6 gigahertz capable. And most importantly, the outer band here will show us, how many of those 6 or how many of those 9 are actually configured. Are they radio configured for 6 gigahertz? I see that 5 of my 9 are not, and they're grayed out. So I can click on view details and continue on with the troubleshooting. I know we're at the top of the hour. I just want to let you know that in the beginning, Tom shared this unplugged channel on YouTube. He had a link, which is the YouTube / at the symbol @get unplugged. And we do have an episode dedicated for advanced 6 gigahertz visibility with my colleague Benny Chung that we go over 30 minutes how to utilize this information in detail, and this dashlet and a lot more dashlets in DNA Center, how to leverage your progress on 6 gigahertz adoption. With that, I'm going to pass it back to Tom and see if there are any questions.
There are no questions right now, Zach. Great job. Great demos. And Orestes, thank for your discussion to kick us off. That was fantastic. Again, as Zach mentioned, the recording and the presentation, along with a lot of other great content, I will send that all out in an email today, summarizing it with the PDF slides. You'll have those at your disposal, along with access to our Get Unplugged channel on YouTube. So go out there to find all the great information. Please fill out the survey when we end the call. And most of all, thank you for joining us for the last hour. Sorry we went a little over, but a lot of great information from both our speakers today. With that, have a great day. We'll talk to y'all soon.